Alright guys, welcome back. In this lecture, we're going to talk about some of the basics of Python. Like I said in the previous lecture, Python is going to be an important skill for you to have to successfully finish this course. So we're going to use Python a lot during the lecture, in the lab sections, for your homeworks, assignments, projects, and things like that. So it is important for you to have a certain level of proficiency in Python. We're not, by the way, requiring a really high level of proficiency of Python. So as far as you understand some of the basic concepts, you should be fine throughout the semester. So to test if whether or not you're proficient enough to take this course, if you go to Icon, there's a quiz problem. There's a set of quiz problems. If you can crack through it without a problem, then you should be good to go. However, if the problems are too difficult, or if you cannot pass the quiz, then that is good. That is a good reason for you to take this lecture. Okay. So if you're already proficient enough, this lecture is going to cover really basic stuff. So feel free to just skip ahead and then move to the next lecture. However, if you're not so proficient, then this is going to be a good chance for you to kind of go over some of the basic concepts of Python, and then become more familiar with it. Okay. So what I want you to do is to go to Icon, and then there's got to be a Module 1 Introduction, and then under that there's a 1-4 Python Basics. Okay. So click on that, and then there's got to be a button which will pop up a new tab that directs you to a Google Colaboratory. Okay. So this is a notebook that I prepare for you to master, well, not master, but kind of for a crash course in Python. Last time we talked about how to use Google Colaboratory, so I'm not going to repeat that too much. So section 1 is basically for you to learn how to use Jupyter Notebook, which is basically what Google Colab is for. I'm going to skip ahead to section 2, where we talk about data types. So in Python, there are data types. If you're already familiar with other programming languages, you probably know what data type is. So in Python, we have a couple of different data types. So the first thing you want to know is the string data type. So string variables are the ones that are surrounded by quotation marks. So single quote, double quote doesn't really matter. It's the same thing in Python. So, well, let me create a new code cell. So basically, whatever you type over here, okay, between the quote, then this is basically how you define a string variable. So something like this. Okay. So you can obviously print like this. Oh, sorry. Yeah, this message basically is giving you a warning that this notebook, it may not be safe, but don't worry, this is what I and my TA has written. So there's no danger. So I just clicked run anyways, and then you can see that the result of running the cell, okay, which is basically that string that I just defined. Okay. So again, single quote, double quote doesn't really matter. So if I change this single quote to a double quote, the result will still be the same. Okay. Now, an interesting thing is in Python, for your convenience, there's some algebraic operations defined. So for example, let's say I have another string variable that says, I don't know, just hello world. And then if I type string variable 1 plus string variable 2, then what it does is basically to concatenate the two string variables together. So now we have a long string that is a combination of the two string variables. So that's the addition operation in strings. So this can be really convenient. So like in this example, let's say you want to print out a message that welcomes the user, right? So basically what you can do is to let the user to type their name, or or retrieve the username from the database, right? So so for example, Jane Doe, and then you can make a program that prints out a welcome message for Jane Doe, or for whatever user is using the system, right? So this can be really convenient way of manipulating strings. Okay. Another thing I want to mention is, let's say you want to repeat the same string over and over again. So like for example, let's say you want to print something like a bunch of dash lines. Okay, so this is kind of a retro way of drawing a line on the screen, right? So you can do this, or if you don't want to type the same thing over and over again, you can just multiply that by, I don't know, 20. Okay, so you can see that the dash has been repeated 20 times. Okay, of course, if you want to have a longer line, then you can go ahead and change the number, and then the character will be repeated multiple times. And it doesn't have to be necessarily a character. So for example, let's say you want to do something like this, then what's going to happen is, basically this string is going to be repeated multiple times. Okay, or let's say it doesn't have to be just special characters. It can be whatever string that you type. So you can multiply the string by some scalar number, and then what you're gonna have is the repetition of the same thing. So again, another example is you can just type a variable name and then the same thing. Okay, so you can see that the string Go Hawks is repeated 50 times. Okay, or you can do something like this. Okay, and then let me get rid of this. And what happens is, the string Go Hawks is repeated 3 times. Now the string variable 1, right, is this entire thing, right? And then I just added it together with string variable 2. So now we have Go Hawks, Go Hawks, Go Hawks, hello world. Okay, so that's basically the algebraic operation that is defined as strings. Okay. The other type of variable is integer. So integer is literally integers, and what you can do is basically you can do all the arithmetic operations. So addition, multiplication, subtraction, division. So all of them are defined in Python, and like many other languages, the symbols are the same. Okay. Now, for integers, if you're already used to C, C++, you probably are a little bit concerned about the division, right? So in C++ or C, if you divide an integer by integer, then the result is going to be integer. So it is going to return actually quotient. But in Python, division is literally just a division. So 3 divided by 2 is going to be just 1.5 rather than 1. Okay. So the quotient division is actually defined as double /. So in this example, we are dividing 32 by 3. Okay. So then the quotient for that division operation is 10, right? So if you run this code, this line is going to print out 10 as the answer. For the remainder, it's the same as C++ or C. The percent symbol is the remainder division. So 100 divided by 3 is going to be 33 and the remainder of 1, right? So the result of this line is going to be 1, okay? Now, if you're a C user, then what you're going to like is the power operation. So in C, you have to, there's no default operation defined for power. So you have to import a math library and, use the function in there. But in Python, power operation is defined as a double multiplication symbol. So 2 star star 10 is basically 2 to the 10th power. So if you run this line, you can check the result. So 2 to the 10th is 1024, as you know. And then, like I said earlier, 32 divided by 3, the quotient of that division is 10. And then the remainder of this division operation is, like I said, is 1. Okay. So that's about integers. Nothing really special. I just wanted to mention the arithmetic operators. Now, moving on to the float data types. Float data types are, basically a data type for, holding numbers, right? So not just the integers, but, also any, numbers can be represented using float data types. So this is something that we're going to deal with quite a bit. I mean, most of the time. So I guess I don't need to explain all of the arithmetic operation. It's basically, the same thing. So addition, multiplication, subtraction, division. Again, it's the same thing. So this is something you would just expect, what you would expect from a mathematical operation. Power, it's the same thing. 2.4 power of 2. It's going to return 2.4 times 2.4, right? The quotient and the remainder is a little bit interesting. Well, so the quotient division is going to give you literally the quotient, but in the float format. Okay, so 32.1 divided by 3. Okay, so then we have 10, and the remainder is 2.1. Okay, so 10 is going to be returned as a result of this quotient division, but 10 is going to be returned as a floating point number. So instead of just integer 10, it's going to return 10.00000000. Okay. Same thing with the remainder operation. So 102.53 divided by 3. The quotient is 34, right? 34, and the remainder is 0.53. Okay, so this operation is going to return 0.53 as a result. Now, you may find something really interesting. Okay, so it seems like the answer is kind of correct. Okay, so as you can see, the last operation over here, the last line over here, the answer is 0.53. But what is this 0.0000000011? Right? So this is because of a numerical error. Okay, so this is something that you have to be careful when you use floating point numbers. I'm not going to go into the details because that requires some understanding of computer science. But the way that because of the way that computer handles the floating point numbers, there can be some error. Okay, although negligible, there can be some error in the numerical digits. And when you have a large enough data, okay, and then especially if you're accumulating a number or accumulating numbers, or keep multiplying some number to a large quantity of variables or whatsoever, when you have a large scale, this can actually create a problem. Okay, when this is a single number, then this is negligible, right? Because 0.53 and lots of zeros, and then 1 1. So it's negligible. But when you have, let's say, millions of data points, millions of such numbers, and then you're adding them together, and this kind of error can accumulate. Okay, so that's why actually programmers have partly why programmers have bothered to create two different data types, integer and floating points. Okay. So this is something that you want to keep in mind. I mean, I'm not gonna talk about the remedy for for this kind of phenomenon, and I'm not gonna talk about any more details about how to take care of this kind of strange phenomena. I mean, you see that the weird errors are included in the operation. Okay. So I'm not going to talk about any more details, but this is something that is worthwhile that to keep in mind, because in the future, when you see some weird behavior, quote unquote, then you know where the problem may come from, and then um, find a solution, right, for that problem. But for today's lecture, that's probably enough. Okay, and then we're going to move on to the next variable type. So the next variable type is a Boolean data type. So Boolean is basically binary, so true or false. Okay. So for true or false, you can have a lot of logical operations. So not operator is an operator that flips the variable. So if a variable is true, then not true is going to return false, obviously, right? If the variable is false, then not false is going to return true, right? Um, you can compare two Boolean variables using this double equal sign. So single equal is, like in many other languages, is an assignment. It doesn't literally mean equal, okay? So to compare if two things are the same or not, then what you're going to do is to type double equal. And then this is basically an AND operator. So when sorry, not an AND operator. This is basically going to return true when the left-hand side and the right-hand side are the same. So in this case, we have true equal false. So that's obviously false, right? So the result of that is going to be false. By the way, as you can imagine, the left-hand side and the right-hand side doesn't have to be a Boolean value. So it can be something like 3 and then 1. So then the result of that is obviously going to be false, because 3 is not that doesn't equal to 1. Okay, so left and right can be some mathematical operation. So let's say 5 plus 3 equals to 1, and then Python will this double equal operator is going to check if the left hand side and the right hand side is the same. Okay. Now another interesting thing I want to mention is, and this is something that C programmers will really like, which is I'm going to convert this into a string. So say hawk, and then on the right hand side eagle. So what Python does is obviously to compare two string variables, and then if both of them are the same, then it's going to return true. But when something is different, so for example, instead of capital H, let's say lowercase h, then it's going to return false. Okay, so it's kind of neat, right? The opposite of the equal operator is the exclamation mark equal. Okay, so this is basically not equal to. Okay, so true is not equal to false. So obviously the result of this, the evaluation of this line, is going to be true, right? So it does basically the same thing as the equal, but it's kind of the opposite, right? The less than, greater than operators, those are basically, literally comparison, which one is bigger and which one is smaller. And we just explained that you can compare the numbers. Now, one thing interesting is the comparison between floating point number and the integer. So in this particular example, the result is the same, but it may not be necessarily the same all the time. Okay, so this is something you have to be careful. Okay, because of this. Because of this. So when a floating point is involved, so let's say my variable holds 3.0, and then because of some computational issue, let's say it contains some error like this. Okay. Now, obviously, if you do this, then it'll say false. They're not true. Okay. So this is a common mistake that the beginners make. I mean, it's not just for Python, but for all the other programming languages. Okay. This is a very common mistake. So when dealing with floating point number, you have to be extra careful. And one of my, well, this is not the only solution, but one of my favorite ways of doing this is to measure the difference, right? And then make sure this is 0, okay? So then, or sorry, not exactly 0, but smaller than some small number, okay? Smaller than an epsilon, right? So this is, let's say, the tolerance of the numerical error, okay? And then if I do the comparison in this way, now I have true, okay? So what it does is basically it ignores beyond certain point, right? Whatever numerical error is involved, it ignores beyond certain decimal points. So this is kind of my favorite way of dealing with floating point numbers, but there can be many other solutions. So the point here is you have to be careful when you use floating point numbers. Okay. The two other operators that I didn't mention yet, and or. Okay, so and is a logical and. So when the left and the right are both true, then it's going to return true. Okay, so false and false is false. True and false is false. So if a false is involved in any side, then the result is going to be false. So the AND operator returns true only when the both side, okay, left and right, are true. Okay. OR operator, same thing. I mean, kind of the opposite. So you know, if true is involved in either side, then the result of that is going to be true. So true or true is true. True or false is true. False or true is true, right? But false or false, because then there is no true, right? So in this case, the result of that is going to be false. Okay. Now, this is kind of the final thing regarding the data types. You can cast the types. So casting means you're converting data types. Okay. So for example, you have a floating point number. You can convert it to a string. Okay. So this can be useful when you want to print the numbers on the screen, or create a, I don't know, create a string variable. Right. So when you want to convert numbers into string, it's going to be very useful. So to do that, you can just type str, and then within the parentheses, you just put in a number. And then as a result of that, you'll see 32.0. I mean, it looks like a string. Sorry, it looks like a number, but what it really is a string that contains these characters. Okay. Same thing with the Boolean variable. So string of true is going to be a string that contains letters TRUE. Okay, so it's not, it's not Boolean. It's really just a string. You can convert things into integers by using int function. Okay. Now, when you convert a floating point number to integer, then the result of that is going to be only the integer part. Okay, so no matter how complicated numbers that you have behind the floating point number, all of them is going to be excluded, and then only the integer part is going to be taken when you convert floating point number into an integer. A string to integer, so given that your string contains numbers, it's going to be converted to an integer. So this is what actually happens when you parse a data set. So usually a data set is, is provided as kind of a text file. So CSV is basically a text file that you can open up in Notepad or whatever text editor. XML is another data type. JSON is another data type. And, in there, things are written in text. Okay, so everything is written in string. So you have to actually extract numbers from that, that bunch of strings. And that is, a process called parsing. And when you parse a text data, then this is an operation that you're going to use a lot, right? So let's say you have a string that contains numbers, right? So then by applying the integer function, the int parenthesis, you can convert that into an integer number, okay? True and false, those Boolean variables. True is basically 1 in computers because it's a binary, right? So 1 or 0. So true integer is going to be 1 and false integer is going to be 0. Okay, simple as that. Of course, we can convert things into floating point numbers. So 32, which was an integer, now is converted to float. 32.0 in string can be converted into a floating point variable. Boolean operator, the Boolean variable, true, which is 1, when you convert into float, then it's going to be 1.0. Boolean false, again, it's 0. So when you convert it to float, then it's going to be 0.00000. Okay. Same thing with Boolean. So for Boolean, what you want to know is 0 is false and everything else is true. Okay. So only when you enter 0, you're gonna have false. Okay, like here, and then everything else, like 1 or 3, whatever, is going to be true. Okay. Finally, this is kind of an interesting feature, which doesn't make too much of sense, but it's quite convenient. So Boolean function, so casting from string to Boolean, okay, is going to return true if the string is not empty, and it's going to return false if a string is empty. Okay, so whatever you type in, yes, no, or hell yes, whatever, Boolean of that is going to be true. Okay, because it contains some characters in the string, right? But when you have an empty string, so between the quotation, there's nothing. So the Boolean of that is going to be false. Okay, so that's for convenience, not really for making sense or anything. The reason why this is convenient is, again, when you, for example, parse data, then some columns might be just empty, right? So then in that case, you can simply test if the a certain entry is empty or not, right, by taking the Boolean operation. So that was typecasting. So there are a few examples which you can play with. So I'm not gonna go through all of them. Instead, let me go to an if and else statement. So in Python, In Python, if and else statements are defined like this. Okay, so if some condition, colon, and then statements. Okay, so the statements to be executed when this condition is satisfied. Now, it can be paired with else or something called elif. Okay, so if this condition is not satisfied, then it goes to the next block. Okay, in this case, elif. So elif is for else if. Okay, and then there's another condition. So if the condition 1 is not true, then we go to the next condition and then evaluate the second condition. And if the second condition is true, then we're going to run this blocks. If the second condition as well is not true, then we're going to go to else. Okay, so that's basically how it works. And if you're already familiar with the other programming languages, this should be fairly simple, right? The only thing, which I think is a major difference between other programming languages, is that there's no curly braces. Okay, so this is something that bothers you a lot if you're, for example, a C programmer. Okay, that's actually what happened to me as well. So when I first came across Python, I was largely bothered by the lack of curly braces. Now, instead of curly braces, what Python does is to use the tab, the indentation. Okay, so the things that are under the same indentation are considered to be under this if block. Okay, so the indentation is basically the way that you define the block. So that's the difference between Python and C languages. Okay. Now, this can actually create some issues. Okay, so for example, this is a perfectly fine if and else pair, but let's say I messed up the indentation, then it's gonna complain. You see, unexpected indent, because they're not in the same level. Okay, of course, what a psychopath, right? I mean, who would do this? So you would argue that this is perfectly convenient, but the problem happens when you use the tab key as opposed to spacebars. So in Colab, you don't have to worry about it because tab key is converted to double space. Okay, so for example, there's no indentation originally, but I hit tab key, then it's gonna insert 2 spaces in front of print. But in case of other text editors, okay, they don't necessarily convert tab key to multiple spaces. Okay, sometimes tab key is just a tab key. So tab is a different character, right, when computer parses your text. And in that case, from the editor, there's no difference visually, but when the computer parses that, code, it recognizes the difference and then it complains about it. Okay, unexpected indent. So that can be a little bit bothersome. I mean, it's not horrible because I mean, tab key is not recommended by not so many programmers use tab keys like as is, literally. They prefer to convert it to spacebars. So usually the development environments automatically converts tab key into spacebars, but still, sometimes it can create some unexpected problems. And sometimes, especially when your code is really long, very difficult to debug. So, yeah, that's one thing I wanted to mention. But other than that, if and else statements are pretty simple. So you have a condition. Okay, so you have a condition here, and then if the condition is satisfied, then it's gonna print this message over here. else the other message. Okay. So of course you can skip else statement like in many other programming languages. So in that case, a command is going to be ran. A command is going to run only when the condition is satisfied. So I'm not going to spend too much of time explaining the if and else statements, because if you're already familiar with other programming languages, then it should be pretty easy to understand how things works. So the only thing that I wanted to emphasize was the indentation. Okay. Now the next thing is a loop. Okay, so like other languages, there's for loop and while loop. For loop, I think personally is more. I guess for loop in Python is easier to understand than C++. I think it's more intuitive. The reason I'm saying that is this is basically how a standard for loop looks like. Okay, so range 3 is a function that returns a list of numbers. Okay, from 0 to 3, and then the 3 is exclusive, so 3 is not included in this range. So range 3 is going to return a list of 0, 1, and 2. Okay, so then the for loop is basically running the commands, okay, by substituting x with the elements of this list. Okay, so it's kind of handy, right? And it's very intuitive. Like for all x in a list, run this, right? As opposed to the C style for loop, where you have to define the initial condition and then the termination condition and then the increment, right? This is, I think, more intuitive way of defining for loop. Okay, so range command is can be paired with for loop. Okay, to create a list of indices, right? So this is quite common when you want to just count the index, right? So x is basically a counter or an index variable, right? And then we're counting up from 0 to all the way through 2. Okay, 3 is exclusive. If you want to count from a different initial condition, then you can type 2 and 6. So that means indices between 2 and 6, and 6 is exclusive. So 2, 3, 4, and 5. 6 is not included. If you want a different increment, the increment can be typed at the end. So 2, 20, and 3. And what that means is I want the indices from between 2 and 20. And 20 is, again, exclusive, with the increment of 3, right? So we're going to have 2, and 2 plus 3 is 5, and then 8, 11, 14, 17, and 20 is not included. Okay, so 17 is the end of the index. So it's fairly simple. Now, the reason why this can be really useful is, let's say you have an array of, we haven't talked about array yet, but let's say we have an array of some random numbers. Okay, so I have 14, 32, and 9. So what you can do is you can create a for loop like this. And what it does is basically, it substitutes x with all the elements of this variable. Okay, so this can be actually very useful, right? And it doesn't really have to be just array of numbers. It can be an array of strings and a lot of different things. So when you want to just go over a list of elements and then apply the same operation, Python has a very intuitive syntax to let you do that. So This is something worthwhile to note. And here's while loop. And for me, I'm not a big fan of while loops. Usually I go with for loop and then I'm happy with it. But some rare cases, while loop is needed. So while something something, and then you have statements. Oh, by the way, I forgot to mention that again in for loop, curly braces again are replaced by indentation. So you have to be very careful with the indentation, especially when you have double for loop. Again, this is something I don't like really as a C programmer. Um, Indentation is basically the way to define the hierarchy. So here we have a nested for loop. So within for x, we have another for loop for y. Okay, so this line has the same indentation with this line. So what that means is this line belongs to the first for loop for x. Okay, and then this line, which is one level further in the indentation. Okay, so this one belongs to the second for loop. So once you get used to it, it's kind of okay. I mean, some people don't want the curly braces because they think that the curly braces make it difficult to read the code. But if you're trained with curly braces, it's kind of bothering. It's kind of annoying. But once you get used to it, you'll kind of become familiar with it. So you can leave with that. Yeah, back to while loop. So while loop is basically the same thing. Instead of curly braces, we use indentation. While loop is the same as C++ or other languages. So while some condition is satisfied, keep running this, right? So there are a lot of examples of how you can use while loops. So I'm not going to explain too much of it because it's basically the same as many other programming languages. All right, so that was about condition statements and then the loops. Now we're going to talk about some advanced data types. So in Python, we have lists, tuples, dictionaries. So list is basically an equivalent of an array. So the native Python does not have an array. It's called list. And the reason why it's called list is because it's not literally an array. I think the nuance, the difference between list and list and array is the fact that the list can contain elements that are heterogeneous, whereas array must contain elements that are homogeneous. So here it's an homogeneous array. We have string, string, string. So all the elements are string. So this is perfectly fine in list, but it also allows you to put in, instead of apple and banana, you can put in apple, 3, and 3.767, yeah, true, and cherry. And this is perfectly fine in Python. So if you print that list, the compiler is not going to complain at all because this is perfectly legitimate way of defining a list. Okay, so this can be kind of cool because you don't have to really worry about the data types, right? You can just put in whatever you want to put in and then build a list. Okay. So that's that. And then the other thing is, well, like I said, I've already shown you that a list can actually be used in for loops. So basically, you have a list of fruits here, and then for I in this list is basically going to go through all the names of the fruits and then print them out. Okay. You can index a list using square brackets. Okay, so this for loop may look a little bit complicated, but once you get used to it, this is actually something that you will see a lot. So what it does is len is a function that counts the number of elements, so length of the list. So we have 1, 2, 3, 4, 5, 6, 7 elements. So the length of list is going to be 7. So if you replace this with 7, I mean, this is basically the for loop that we already seen in a few cells ago, right? So then what it does is it counts up from 0 all the way through 6, because 7 is exclusive, and will access the element, okay, of that list by using that index. So I think this one example shows a lot of things. First, how to count the number of elements in the list, but also how to index the variables. So this for loop and this for loop, those are basically the same thing, okay, if you just compare the output. Okay. Now, in Python, there is this thing called tuple. And tuple is basically the same as a list, okay? So you may even wonder why the two things exist at the same time. Because the only difference between tuple and the array is that in case of array, sorry, not array. I'm so used to C++. It's a list. Sorry. So the difference between list and the tuple is that list is defined by square brackets, whereas tuples are defined by parentheses. That's, the I would say for beginners, that's the only difference. Of course, there is a reason why they coexist. There are different uses, okay? But I guess for beginners, you don't have to really worry about the difference between list and the tuples, okay? So again, a tuple is a collection of, things, okay? You can have, instead of banana, we can have 7, right? And then run the code and it'll be perfectly fine, okay? And then the way that you access the elements is the same. So within a square bracket, you just put in the index. So in this case, 0th element and the first element. So the first element is going to be printed. Sorry, maybe this one. Yep. In terms of for loop, again, it's the same thing. Okay. So you can use for loop with the tuples. So practically, there's no difference between tuple and an array for now. Okay. Once you become more advanced programmer, then there are some differences. But for now, let's just agree that the tuples are the same as lists. So in this lecture, most of the time, I'll be just using lists instead of tuples. Okay. Now, this is a really neat thing called dictionary. So dictionary is another data structure that's available in Python. If you are familiar with C++, then this is kind of sort of similar to map data structure in the standard library. If you don't understand what I'm talking about, that's perfectly fine. A dictionary is a pair of key and value. Okay. So key is literally a key or kind of an index. And then value is the actual value you're interested in. So here's an example of a dictionary for holding information about a car. So under the dictionary, we have the brand, we have the model, we have the year, and the actual values are Jeep, Wrangler, and 2010. Okay. So that's basically how you define a dictionary. And when you define your dictionary, curly braces are used. Okay. And then you type a key name, colon, and then the value, comma. Okay. So that's basically how you define a dictionary. When you access the elements of dictionary, you can either use the square bracket like this. So dictionary, square bracket, the key name, then it's going to return the value associated with that. Alternatively, this is basically the same thing. You can do the dictionary dot get and then key name. Okay, so this is basically the same thing. You can also change the value of a field in the dictionary. So the year previously was 2010. Now you want to change it to 2020. So then what you can do is you can access by using the square bracket and then just change, just assign the value to that. So it's fairly simple. Now, the length function also exists for dictionaries. So in this dictionary, we have 3 elements, 1, 2, and 3, right? So length of the dictionary is going to be 3. And there, 3 it is. What else? Yes, you can add the new key and new value pair. So for that, simply just type something that doesn't exist already. It's as simple as that. Okay, so Python will then recognize, oh yeah, the user wants to create a new key and then assign a new value to that new key. Okay, so then after doing this, if you print the dictionary, now you can see that the new key called color is added to it. Of course, if you can add something, you can remove something. So for that, pop is an operation. So the dictionary dot pop, the name of the key. So then it's going to remove the key from that dictionary. Okay, and it doesn't have to be a new one. So if you want to remove ear instead of collar, then there you go. Okay, instead of collar, now the ear is removed. So that's basically how you work with dictionaries. So dictionaries can be, really useful if you are dealing with some structured data set, right? So as a data scientist, dictionary is something can be very useful and quite powerful. All right, so again, there are many examples and many exercises that I'm not going to cover in this video, but I recommend again for you to kind of go over all the exercises and examples. Now, we're going to change the gear a little bit. Here we talk about functions. So functions are literally functions. Some input comes in and some output is, spitted out. Again, if you're familiar with other programming languages, Python functions are not really special, except that there's no those ugly type definitions and things like that. So any arbitrary values can come in. Okay, any arbitrary variables can come in, and they don't necessarily have a predefined, explicitly defined data types. So in case of C, you have the return type of a function, and then you have data type for each of the variables. So int param1, float param2, double param3, and so on and so forth. In Python, you don't have all that. So the data types are implicitly assumed in functions. Another difference is that the functions are defined by the keyword def. Okay. And then again, there's no curly braces, so just a colon and then the indentation. Okay. But other than that, it's basically the same. It's basically the same. You don't need to have the inputs. So you can have a function that doesn't require any input. You can also have a function that doesn't return anything. So it's basically the same as, functions in other programming languages. So this is a simple usage of how to define a function and how to use it. So again, pretty simple, right? What else? Yeah, this is what I mentioned. So let's say you want to create a welcome message, right, to a user. So you can define a function like this, and then use this function for your need. So again, there's nothing really much in terms of functions. So again, this course assumes that you're familiar with at least one programming language. So, yeah, if you're familiar with C++ or C or MATLAB or whatever, functions are pretty much the same. So I'm not going to go too much into the details. Okay. Now, here's this thing called Numpy. Okay. So, Numpy is for numerical operations in Python. Okay. So Numpy is an external, Numpy is an external library, okay, that is not included in native Python. And the reason why I'm mentioning Numpy is that Numpy can be very, very useful for any type of scientific computing. So if you're using Python for number crunching, Numpy is kind of an essential tool. Now, in Python, importing library is as simple as import the name of the library, period. That's it. So import NumPy is the way that you import NumPy to Python, and then you can use NumPy after you import like this. You can assign a nickname to the library. So when you have, sorry, let me pop this up. So when you use NumPy, so well, I'll just create a new example. So import NumPy, and then this is basically how you use NumPy. Okay, let's just print this. This is basically how you use NumPy. So you can create an array, you can do a matrix multiplication, you can do basically lots of numerical operations using NumPy. Now, when you type the code, typing the name of the library all the time is kind of inconvenient because we have 5 characters, and programmers tend to be lazy, right? So you can assign a nickname. Okay, it's called an alias. So import NumPy as NP. So then you don't have to type NumPy all the time. You can just go by NP dot something something. And in fact, NP is a really popular nickname for NumPy. So almost all, like 99% of the programmers use NP as a nickname of NumPy. So this is kind of like, how do I say? A standard thing for many people. So import NumPy as NP is kind of a default statement. Now the usage of NumPy is pretty simple once you get familiar with some of the basic functions. So first of all, np.array is a very useful function that converts a list in Python into a NumPy array. Okay, so by doing this, okay, so if I run this, okay, what happens is the list 14253 is converted to a NumPy array 14253. Okay, now when all the elements are integers, np.array is going to recognize that and then create an integer array. But there's one constraint. NumPy arrays are homogeneous. Heterogeneous arrays are not allowed. Okay? So what that means, the consequence of that is if, okay, one element is a floating point number while the rest is the integer, then Python is going to recognize that, and then because it has to be homogeneous, it'll just make it a floating point array. So the integers 4, 2, and 3 are going to cast up to floating point numbers. Because floating point number is a bigger concept, right? So integers belong to floating point numbers. So NumPy will automatically recognize that and then create a floating point array. Now, what happens if I have a string? So instead of 4, let's say we have 4 as a string. Now, if you do this, then it's going to create a string array. So this is kind of neat. Again, string is a bigger concept if you think about it, because no matter how complicated your number is, you can convert that to strings. Okay. So the point here is NumPy enforces homogeneous arrays, whereas in Python native lists, different data types, heterogeneous data types, can coexist. Okay, that's the key over here. Now, sometimes you want to be explicit and say, hey, I have a list of integers, but I want to create a floating point array. And for that, this is something you want to do. Okay. Now, what if I put that, what if I put that in this code? So I'm forcing to convert this array into floating point. In that case, well, your compiler complains because there's no way, there's no trivial way of converting this string into floating point number. Okay. What if we do this? We have a floating point number, so the rest are integers, so they have no problem. So this is a floating point number. What if we do this? If we do this, then the floating point number is going to be casted to integer. Now, what's this 32 is all about? Well, this is something that gets a little computer sciencey, but 32 is the resolution of the numbers. So 32 means 32-bit integer. So I hope you understand the basic concept of bits and bytes, right? So 8 bits constitutes 1 byte, right? And then 1,000 bytes are kilobytes, and then 1,000 kilobytes are megabytes, and 1,000 megabytes are gigabytes, and so on and so forth, right? So that's basic, like the unit of information, right, represented in computers. So the higher byte you have, the more digits you can represent. So you can resolve smaller numbers. So int 16 is a 16-bit integer. And 16-bit means, we have 16 zeros and ones. So let's, for the sake of convenience, let's go with int 8. So 8-bit integer. So 8-bit integer means we have 8 binary digits, right? So this is 0, 0, 0, 0, 0, 0. That's 0. And then, binary, binary numbers, right? So it can be 0, 0, 0, 0, 1. So this is basically how the computer represents the information. Now, if you think about it, there is a limitation, right? So 0, 0, 0, 0, 0 is 0. And the largest number you can represent with that 8-bit integer is 1, 1, 1, 1, 1, 1, 1, 1, right? Because it's a binary number. And that is what? That is, so this digit over here is 2 to the 7th. So I'm going to be explicit, right? Oops. So this is what this digit represents, right? So, and this is basically 2 to the 8 minus 1. So that's the largest number that you can represent using int 8. Okay. And what is this value? So 2 to the 8 is 128, right? So we can represent from 0 to 127. And anything that's beyond that, we're not going to be able to represent. And that's, an example for an unsigned integer, in fact. And usually one digit, okay, in this binary are dedicated for a sign. So either plus or minus, right? So when you have a plus minus sign, then the range of the values that you can represent gets much smaller. Gets half of this. So in case of signed integer, you're going to have negative 64 to 63. So that's what 8-bit integer does. So obviously this is too small, right? Because you can count numbers bigger than 127, right? So then what you can do is you can add more digits like this to increase the resolution, increase the range of the values that you can represent. So and when you do that, it's always better to count up by 8 because 8-bit means 1 byte. So 1 byte is basically the smallest chunk, right, in many data representations. So int 16 is basically 8 more digits than that. And if you think about it, the total number of, for 16-bit integer, the total number of, what am I going to say? The total size, right? The biggest size of the value that you can represent using the 16-bit integer is this, which I believe, and this is, I'm not quite sure, but something like this. 65536. So 65,000 values can be represented using 16-bit integer, which sounds like a lot, but not quite if you think about it, right? So int 32 then is 32-bit integer, which is 2 to the 32 and minus 1. So that's a lot, right? That's a lot. So that's, what this, 32 at the end of int is all about. So 32-bit integers, 32-bit floating point numbers are usually fine. If you want to do more precise scientific computation, int 64, float 64 are options. Okay. I believe Numpy used 32-bit as the default. So if you don't really specify anything, then Numpy will just recognize it as floating, float 32 and int 32. Okay. Now moving on. So that's Numpy, and then again, I'm not gonna go over all the examples, but there are a lot of examples where you can learn how to create arrays in different manner. So for example, when you want to create an array filled with zeros, this is something you want to do. And if you're a MATLAB user, by the way, you will find this awful lot similar to the MATLAB syntax, because I don't know, I'm just assuming here. I think the design principle of Numpy was to make it compatible with MATLAB, because that's what people are already familiar with. That's my hypothesis, but maybe I'm wrong. But anyways, it looks actually quite similar to MATLAB syntax. So if you are familiar with MATLAB, this is going to be very, very simple. If you're not familiar with MATLAB, just think of them as kind of a convenience function. So for example, in C++, there's no way to, zeros is okay, because you can create an array filled with zeros in C++ as well. But for example, array filled with 3.14, or creating an array that is, that has values evenly spaced between some range, those kind of things doesn't exist in C++. So you have to, create an array first and then write a for loop or while loop right? And then you have to manually do all that. In Python, things are pretty simple. You can just type one line, and boom, you have everything. Okay, so we talked about data types already. Now, there are some things I want to mention regarding the operations involving NumPy arrays. So NumPy arrays are, you can consider them basically as matrices or tensors. So you can create an array of one dimension, and one-dimensional array is basically a vector. And then two-dimensional array is basically a matrix. And then you can have a higher dimensional array, which is quite common, by the way, in data science, especially when you deal with neural networks. Higher dimensional arrays are basically higher dimensional tensors. I'm not gonna give you a math lecture, but that's basically what it is. And what that means is between arrays you can do tensor algebra. So you can add vectors to vectors. You can multiply vector with a matrix. You can multiply matrices. You can multiply matrix with a three-dimensional tensor, and so on and so forth. All of this tensor algebra is available in NumPy, which is kind of the strength of NumPy. So here we have examples explaining all those concepts. So the first thing you want to know is the indexing. So when you access the elements of an array, so let's say we have a one-dimensional array called x1, accessing the elements using the index is pretty much the same as the native Python list, right? So I'm not going to go into that. This is something I did not explain when I was talking about the lists. Python has the negative indices, which is quite convenient when you want to access the list from the end, not from the beginning. So this kind of negative indices are available in NumPy arrays, but also in the Python native lists, okay, or dictionaries or tuples. So -1 as an index means the latest element, the last element in the array, and then you can count backward from that. So -2 means a second from the last element. -3 means the third from the last element, and so on and so forth. When you have a higher dimensional array, then you can split indices by comma. So 0 means the row. The first one means the row, and then the second one means the column. Okay. So the second row and the third column, so element at the second row and the third column can be accessed like this. First row and the last column can be accessed like this. So it's pretty intuitive. You can also use this colon character. Again, this is something I did not explain when I was explaining the lists, and this can be actually quite useful. Okay. So you can basically define the range, okay, by start, stop, and the step length. So it's kind of like for loop in some sense, right? Because we have the initial condition, the termination condition, and then the increment, right? So we have a lot of examples over here, okay? So first of all, this. We have not specified a start, okay, but we specified the stop. So since we have not specified a start, then we assume that we're beginning from the first element. So what it does is it prints the first 5 elements in this array. And 5 is exclusive. And remember, we're counting from 0. So x1 0, x1 1, x1 2, x1 3, x1 4 will be printed out, which is total 5, right? But x1 5 is not going to be printed. So stop index is always exclusive in Python. Okay. So that's how you retrieve the first 5 elements. You can go like first 3 elements, first 7 elements. You can do it whatever you want to do. Similarly, you can specify the starting index, but do not specify the stop index. In that case, it'll just count everything after the index of 5. Okay? So if the length of x1 is 7, then it's going to return x1 5, x1 6. Okay. You can specify both start and the stop. Okay. So in that case, it's basically a subarray in between the index of 4 and index of 7. And again, remember, the start is inclusive and the stop is exclusive. So what that means is the result of running this line is going to be x1 4, x1 5, x1 6, but not x1 7. Okay. Now, so that's the magic you can play with the start and stop. Now, let's say you want to add the step. So that's an increment. So for example, I don't specify start, I don't specify stop, but I specify step as 2. Then what it does is it'll print out the entire array for every other element. Okay, so x1 0, x1 2, x1 4, x1 6, and so on and so forth is going to be printed by running this command. If you want to have a specific starting point, then this is what you can do, right? So at this point, this is quite obvious, right? If you do this, you want to begin with the first element, the index of 1, and you want to print every other element. So in that case, we have x1 1 printed, x1 3 printed, x1 5 printed, and so on and so forth. The step can also be negative. So in case you have a negative integer for the step, then it'll count in a reverse order. So I want the entire element because I did not specify the start and the stop. So I want the entire array, but printed in a reverse order. Okay. So that's how you flip the order of the numbers in a NumPy array. Of course, you can have something other than -1. So in case you have -2, you want to have every other element in a reverse order starting from the index of 5. Okay, so then x1 5, x1 3, x1 1, and then you go all the way back to the end of the array, right? And that's basically how it will print out. Okay, so this can be actually quite useful, especially if you're dealing with some sequence and you want to sample things in every x steps, or things like that. This can be really useful. The same rule can be applied to two-dimensional arrays and higher dimensional arrays. The only difference is that you have comma. So I'm not going to explain how all these things work, but instead I will just move on to views and copies. Now, okay, so here's an example, and let me actually try to. Sorry, I forgot to run x2 here. All right, so x2 is a 3x4 matrix, okay, that is comprised of these numbers. Now, you can create a subarray like this, and x2 sub is a block matrix at the upper left corner of the original matrix. Now what I'm going to do is to replace this, first number, this 5, with a new number, 99. Now, obviously, x2 sub has been changed, but now if you look at it, x2 has also been changed. Okay? So this is something that you have to be very, 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 very careful. Okay? You have to be very careful. By doing this, NumPy does not actually copy. It is just it is just a reference. Okay, it is just a reference to a certain area, a certain subarray of the original array. Okay, and since this is a reference, x to sub does not really hold the actual value. Instead, it has a, if you're familiar with C++, it has a pointer pointing at the 2x2 subarray at the left top corner. Okay? So that's what happens. So, as a result of that, since x to sub itself does not hold any values, what happens is, if you assign 99, then the element that x to sub is referencing is going to be changed rather than the x to sub itself. And that's why you're seeing this result. And you have to be very careful, because a lot of times beginners, they create some derivation from the original matrix, do some modification on that matrix, and believe that the subarray, or whatever derivation, is indeed an independent object. And that's completely wrong. Okay? So this can be useful, because when you have a really large matrix, it doesn't really copy or anything. It just references to that, So you can use the memory space quite efficiently. But in the meantime, the drawback of that is you kind of create a confusion that you're actually copying or extracting something and then create a new independent array. So in order to do that, you have to be explicit. You have to say x to copy. Okay? So here I create a subarray in this manner. Oh, by the way, I just changed the number to 99, so that's why you're seeing 99 still. But now let's say instead of 99, I replace it by 42. Okay? And see what happens. Since I copied the 2x2 block from the original matrix x2, okay, the original matrix doesn't change. Okay? Now x to sub copy actually is an independent matrix of its own. Okay? It's not referencing anyone anymore because you copy the numbers. Okay? So this is something that I really want to emphasize, because I've seen a lot of time, including myself, I made a lot of mistakes like this. And this really stinks because it's really hard to debug, right? So you have to be very careful. Reshaping, sometimes you have, I don't know, you have one-dimensional array with 9 elements, right? And you want to convert that into 3x3 grid. So you can use a function called reshape. So you can then rearrange values. So originally, this np.arange is a function that returns 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. But if you reshape that into 3x3, then this is what you're gonna have. Excuse me. Again, there are a few other examples of reshape. This is the reshape is being used to kind of transpose a one-dimensional one-dimensional array, a vector, into a row vector or a column vector. So it's pretty straightforward. And then I'm going to move on to the concatenation and splitting. You can see that when you have two arrays like this, you can concatenate the two arrays and then build something like this. So as a result of that, you see that we just created a longer array by concatenating the two arrays like this. So Yeah, I mean, concatenate is quite useful function, especially when you have a data set that you want to append to the existing data set. Concatenate is a function that you may want to look up. VStack, HStack, those are basically concatenation, but in more convenient way. So concatenate is essentially for an one-dimensional array. VStack and HStack is for higher dimensional arrays, or in case of mixed dimensions. So VStack means a vertical stack, and vertical means we're stacking the rows. Okay, and then HStack is a horizontal stack, and what that means is we're stacking columns. Okay, so I'm gonna just show you this one example over here. So we have an array that looks like this, 987654. So it's a two-dimensional array of 2 rows and 3 columns. And then we have a one-dimensional array that contains 1, 2, 3. Okay. So what you can do is you can vertically stack X on top of this grid, 987654. So as a result of running this, you're going to have 1, 2, 3, 987654. Horizontal stack works basically in the same way but different directions, so you don't have to worry about it. It's basically the same thing. If you can stack up, if you can concatenate, there's always the reverse function. So you can split an existing thing into 2 parts. You can do it vertically, you can do it horizontally. And sorry, I forgot to mention split. So split is the opposite of concatenation, concatenate function. VSplit is an opposite of the VStack. HSplit is an opposite of HStack. So it's basically just a reverse, so I'm not going to explain too much about it. Okay. Here's an interesting thing I want to mention, actually. And this is something that you'd be already familiar with if you're a MATLAB user. But if you're a C or C++ user, then this might be something new. So there's this thing called broadcasting, and it can be actually quite useful. Okay, so let's consider 2 vectors. Okay, so we have a vector whose elements are 0, 1, and 2, and then we have another vector whose elements are 5, 5, 5. Okay, so the operations between vectors, okay, must include vectors of the same dimensions, right? So you have, if you have a 3-dimensional vector on one side, then you want to have a 3-dimensional vector as well on the other side. So A plus B is perfectly fine. A multiply B, by the way, in vectors, it's element-wise multiplication. And this is perfectly fine operation. But what I want to mention is you can actually add a scalar to a vector. And what happens is exactly like this. Okay? So in mathematics, if you want to be rigorous, okay, a 3-dimensional vector cannot be added with a scalar, right? That's an invalid operation. So in C++, this is not possible. You cannot add a scalar to a vector. But in Python, there's this thing called a broadcasting. Broadcasting is basically forgiving some sloppiness in the mathematical representation. So what it does is, okay, so you have a vector, you have a scalar. I'm just going to assume that you want to add the scalar number to all the elements of A. So as a result of running this, A, remember, was defined as 0, 1, 2. And then if you add 5, it becomes 5, 6, 7. Okay? So that's called the broadcasting. So internally what happens is, that 5 internally is converted to 5, 5, 5 to make the dimension consistent with A. Okay? You can do the same thing, not just for the addition, but also for the multiplication. In that case, you're going to see the same result as this one. So that's called the broadcasting. Broadcasting means that you're broadcasting a number or an element that has the lower dimension. So we have a one-dimensional array and we have a zero-dimensional array, and you're broadcasting the lower dimensional array to match the dimension and match the shape of a higher dimensional array. That's the broadcasting operation. Now, what if I do 5 and 1? Will Python still be able to broadcast this? The answer is no, because there's no trivial way, right, to broadcast a vector with 2 elements to a vector of 3 elements. So there's no way you can broadcast this, okay? So you have to be careful, okay? When you broadcast, you have to make sure that the shapes are compatible. You can repeat basically this, right? You can basically V-stack or H-stack this to create the same shape of A. You must be able to do that in order to do the broadcasting, because that's essentially what happens in NumPy, okay? So that is a very useful operation called broadcasting, okay? Because then, unlike in, without broadcasting, imagine, let's say you have a data matrix and then you have to subtract a mean, okay, from that matrix. And then the matrix is really large. So in conventional C, what you have to do is you have to write a for loop and then go through all the elements and then, subtract the mean, right? Versus if you have a broadcasting, then you can just simply, type x minus some, scalar value that represents a mean, right? So it can be very, very useful. Here's more graphical illustration of how things work in broadcasting. So I don't think I'll need to explain everything, but I'll recommend you guys to take a look at it and then make sure that you get the concept of broadcasting. Finally, we have a few remarks on the Boolean operations. Boolean operations in NumPy, it's pretty intuitive. So the essence of that is, okay, we can broadcast a Boolean operation. So less than 3, an array less than 3 means we're applying this Boolean operation for each and every element. So the result of that is going to be a Boolean array, okay? So true, true, false, 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 okay? Which is what you would expect. So everything is basically in the same, spirit, just the different Boolean operators. You can do the comparison between the arrays, given that the array size is the same. So we have 2 times x and then x squared, right? So if you do this, then again, it's an element-wise comparison. So what happens here is on the left-hand side, it becomes 2, 4, 6, 8, 10. Right? On the right-hand side, by doing this operation, the array becomes 1, 4, 9, 16, 25. Right? And then you're comparing them element-wise. So, well, yeah, it's very intuitive, nothing really special, but can be quite convenient because, this kind of thing, this kind of features are not available in many other programming languages. So that's kind of a unique strength of Python. There are some convenient functions like count non-zero or sum, right? So count non-zero means you're basically counting the non-zero elements. So we have x smaller than 3. So here, let me add one more line, print x smaller than 3. What happens here is, in x, okay, x is 1, 2, 3, 4, 5. And then we're going to create a Boolean array, right, that contains true, true, false, false, false by doing this, right? And then previously we learned that false is 0, right, and true is 1. So if you count non-zero, then what happens is you can count the elements of x that are smaller than 3. And there are 2. We have 1, 2, right? So the result of running that line is 2. Or equivalently, because true is 1, you can basically take the summation over the entire array. So it becomes 1 plus 1 plus 0 plus 0 plus 0, which is again 2. So these two are equivalent to each other. So this is one useful feature, right? So let's say you have a data matrix and you want to count some things that satisfy a certain condition. So for example, you have a data matrix that contains student information, and you want to find how many students are engineering major, for example. So then you can create a logical operation over here, right? You can create a comparison over here, and then just basically count non-zero. Okay. So that can be quite useful. Another useful function is called any or all. So, and the interpretation, the what it does is basically quite literal. So, is there any values greater than x bigger than 8? That's basically what it asks. Okay, so in this case, we have an array 1, 2, 3, 4, 5, and there's nothing bigger than 8. So what it does is basically going to return false because there's nothing that is bigger than 8. What if I change it to 4? So then it becomes true because there is at least one element that is greater than 4, which is 5 over here. Okay, so that's basically what happens. If you switch it to all instead of any, then this statement becomes false again, because all means I want everything to satisfy this. And obviously, in this case, only 5 satisfies that condition, and then everything else is false. So in that case, the result of that is false. Okay. However, if I change it to -1, then all elements in X satisfies this condition, right? So in that case, the answer is going to be true, as expected. Okay, so these are quite useful functions. I mean, useful Boolean operation that involves Numpy arrays. So you may want to take a look into that. And that's the end of our lecture today. And in an assumption that many people are familiar already with MATLAB, especially engineering majors, I think you guys learned MATLAB during EPS2, or it's now called the Introduction to Engineering Computing. So here in this link, there's a table that compares MATLAB commands with Numpy commands, and you'll realize things are quite similar to each other. So if you have by any chance an experience of dealing in MATLAB, this is a table that can be extremely useful. So whenever you want to write something but you're not quite sure how to do it, then here's a little cheat sheet where you can refer to where you can find the corresponding NumPy function from the MATLAB equivalent. If you're not so familiar with MATLAB, that's also fine because I mean it's not terribly difficult to learn. So I guess the point here is once you are familiar, again, this course requires everyone to be familiar with at least one programming language. And if you know at least one programming language, learning Python is not going to be a hell lot of burden because Python is, as you've seen so far, is quite a high-level language, meaning it's pretty close to the human language. So once you get familiar with some basic syntax, I think you should be just fine taking this course. So what I recommend, again, is to go over this entire material and then make sure that you solve the exercise problems and then, try to mess around with that and then, try to see what happens if I change this to 7 instead of 100 and, things like that. So mess around with this material. Again, it will not harm your computer because Google Colab is running on a Google server. And then with this level of code, there's no way to create any harm to your computer or the Google farm or whatever, right? So feel free to just mess around with that, try to change things, see if there's an error. When the error pops up, try to analyze why the error popped up and so on. That's the best way to learn and pick up Python. So please do that. And then after you do that, once you become a little more comfortable and confident about it, try to go ahead and take the quiz. Okay. And then if you can pass the quiz, then you should be good to go. If you cannot pass the quiz, you can take the quiz multiple times. So there's no limitations in terms of the number of attempts that you can make. So you can take whatever number you want to take. So you can take 10 times, 20 times, 100 times. It doesn't matter. So if you cannot pass the quiz, try to go back and try to read the material carefully again, and go back to the quiz and then see if you got any better. And then that's basically my recommendation. Thank you very much. I appreciate you watching this video, and I'll see you guys in the next lecture, which is going to be the overview of Hadoop.